All right, section 5.2, integer exponents and the quotient rule. All right, so first we have the rule for a zero exponent. Anything raised to the zero power is equal to 1. So for example, 17 to the zero power would equal 1. This quantity negative 17 raised to the zero power is also 1. Keep in mind that the exponent only applies to the number right in front of it. So this zero exponent only applies to the 17, and you would carry that negative over into your answer. So this would actually equal negative 1. Again, with this example, the zero exponent only applies to the x, so you would carry the 17 over into your answer. So that's 17 times 1, which is equal to 17. All right, so we want to evaluate 60 to the zero power, and we know that equals 1. Negative 60 to the zero power is also 1 because the exponent applies to the whole quantity. Negative 60 to the zero power, the exponent only applies to the 60, so carry the negative over into your answer. Negative 1. Y to the zero power is 1. 6y to the zero power, the exponent only applies to the y, so you'd carry the 6 over into your answer, and 6 times 1 is 6. All right, the quantity 6y to the zero power is 1. G to the 0 plus 11 to the 0 would be 1 plus 1, and that would equal 2. And then negative 8 to the 0 minus 11 to the 0. Of course, you would carry the negative over into your answer, so negative 1 minus 1 equals negative 2. All right, now dealing with negative exponents. Whenever you have a negative exponent, you want to flip it and make it positive. So a to the negative n, you're going to flip it and make it 1 over a to the n. If your negative exponent is in your denominator, you're going to flip it up to the numerator. So it would be a to the n over 1, or just a to the n. And then if you have a whole fraction raised to a negative exponent, you flip that fraction and raise it to the positive n power, and then of course that n would apply to the numerator and the denominator. So we get b to the n over a to the n. All right, so we want to write with a positive exponent and then simplify. So 3 to the negative second power, we could rewrite this as 3 to the positive second power, and 3 squared is 9. Okay, let's see. The next one is 5 to the negative third power. Rewrite that as 5 to the positive third power. And 5 times 5 times 5 is 125. All right, 1/2. And that whole fraction is to the negative third power. So I'm going to flip the whole fraction and make it 2 over 1 to the positive third power. And then both the numerator and the denominator are raised to the third power. So that would be 8 over 1, or just 8. All right, let's try another one like that. 2/5 to the negative fourth power. So first flip the whole fraction, make it 5/2 to the positive fourth power, and then both the numerator and denominator are raised to the fourth power. 5 to the fourth power is 625, and 2 to the fourth power is 16. Let's do one more. 4/3 to the negative fifth power, flip it and make it 3/4 to the positive fifth power, and then both your numerator and denominator are raised to the fifth power. 3 to the fifth power is 243, and 4 to the fifth power is 1024. Let's see, we do have a few more, so let's see. All right, part F. All right, 4 to the negative first minus 2 to the negative first. We're going to rewrite this as 1/4 minus 1/2. First, you're going to flip to make it positive, and then we're subtracting fractions with different denominators. The LCD is 4, so I'm going to multiply this fraction by 2/2. So now I have 1/4 minus 2/4, and that is equal to a negative 1/4. All right, 3p to the negative second power. Remember that exponent only applies to the p, so you're only going to flip what is negative. So the 3 is going to stay in the numerator, and the p squared goes down to the denominator. All right, but if I write it this way, 3p and this quantity is to the negative second power, then you would have to flip that whole quantity to the denominator. So that would be 1 over 3p, and that whole quantity is squared. So that means everything inside the parentheses gets squared. So that would be 1 over 9p squared. Let's try a few more. 1 over x to the negative fourth. That negative exponent is in the denominator, so now we will flip it to the numerator. So that would be x to the fourth, and that's it. And then let's try one more. X to the third, y to the negative fourth. Again, that negative exponent only applies to the y, so the x to the third will stay in the numerator, and y to the fourth goes to the denominator. All right, with this one, we have a negative exponent in the numerator and denominator. They both need to be flipped. So that would be 5 to the positive third over 4 to the positive second. 5 to the third is 125, and 4 squared is 16. M to the negative fifth over p to the negative first. Again, both have negative exponents, so p to the first comes to the numerator, and m to the fifth goes to the denominator. A to the negative second b over 3d to the negative third. Again, you only flip the exponents that are negative. So this a to the negative second would need to go down to the denominator, and this b will stay where it is. This d to the negative third will need to go up to the numerator, and the 3 will stay where it is. Okay, so you only flip what's negative, and everything else stays exactly where it is. So now in the numerator, I'll have b, and then I'm going to flip up and make this d to the positive third. The 3 stays where it is, and that will come down and become a to the positive second. All right, let's try another one. Okay, x over 2y, and this is to the negative fourth power. Okay, so everything inside the parentheses is raised to a negative exponent, so let's flip the whole thing and make it 2y over x, and now this is to the positive fourth power, and then everything inside the parentheses is raised to the fourth power. 2 to the fourth power is 16, y to the fourth over x to the fourth. All right, let's try this one. Negative 2x over 3, and this is raised to the negative third power. All right, so first we're going to flip it and make it 3 over negative 2x, and now it is raised to the positive third power. Now keep in mind, this is a negative 2, not a negative exponent. So when we raise everything to the third power, we have 3 times 3 times 3, which is 27. Negative 2 times negative 2 times negative 2, which is negative 8. And then x to the third power.